You're looking at a force so powerful it can level a city in like minutes. I mean, think about it. The ground under our feet, the one thing we count on to be solid, suddenly starts acting like a stormy ocean. It's terrifying, right? So what's really going on down there? What's happening inside the Earth to make the whole world shake?
Okay, let's dive right in. We're going to unpack this incredible force of nature and really get to the bottom of what makes our planet tick, and sometimes shake. All right, first things first. To really get a handle on this, we need to know exactly what we're talking about. What is an earthquake? Well, in simple terms, it's a tremor that starts deep below the surface and makes the crust shake. Think of it like a rubber band. The Earth's crust is constantly under stress, building up energy, and an earthquake is what happens when that rubber band finally snaps. All that stored up energy is released in a sudden, violent shock. And get this isn't some super rare event. We're talking about 20,000 earthquakes happening around the world every single year. Now, most of them are tiny, but still, that's a whole lot of shaking going on. So that leads to the next big question, right? What's causing all this chaos? Who's the main culprit behind the shaking? Well, the number one cause, the big kahuna, is something called plate tectonics. You see, the Earth's surface isn't one solid shell. It's actually broken up into these gigantic puzzle pieces, these plates that are always on the move. And when these massive plates grind past each other or smash into one another, bam! That's where most earthquakes happen. And this map just shows it perfectly. Look at that. You can see how all the major earthquake zones just light up right along the edges of these tectonic plates. It's not random at all. It's a perfect match.
But it's not just about plate tectonics. That's the main driver for sure, but other things can set off a quake too. Think massive volcanic eruptions or even human activities, like mining or building huge dams. Yeah, sometimes it's us.
Okay, so we know what causes them, but how do we actually measure them? How do scientists read these fingerprints from the Earth?
It all comes down to a race to the seismograph. See, when an earthquake happens, it sends out these energy waves, and they don't all arrive at the same time. First up, you've got the P waves, or primary waves. Then, the S waves, for secondary, roll in. And finally, the L waves, the surface waves, make their appearance.
And what's super interesting is how they travel. Check this out. The P and S waves, they shoot right through the body of the Earth. But the L waves, they're different. They travel along the surface, kind of like ripples on a pond. And those are the ones that cause most of the damage we see up here.
So to measure all this, scientists actually use two different scales. It's kind of like measuring a storm. You've got the Richter scale, which is all about the raw power, the energy released right at the source. Then there's the Mercalli scale, which is more about the experience, how intense the shaking felt, and what kind of damage it actually did.
Now here's something you really got to understand about the Richter scale. It's not like a regular ruler. Each whole number you go up means the ground shaking is 10 times stronger. So a 7 isn't just a little bit worse than a 6, it's 10 times worse. That's a huge leap in destructive power. It's the difference between feeling a big truck rumble past your house versus that truck actually smashing through your living room wall. It's a whole other ballgame.
Okay, so knowing all that, where on Earth are these things most likely to strike? Let's take a look at the global hotspots. Yeah, it is definitely not random. A whopping 70% of all earthquakes happen in one area, the Circum-Pacific Belt. You've probably heard of it. It's the Ring of Fire, and it's called that for a reason. It's basically where the giant Pacific plate is constantly grinding against a bunch of other plates, making it a major hotspot for both earthquakes and volcanoes.
So what happens after the shaking stops? Well, the aftermath is immense. Earthquakes are obviously a massively destructive force, but, and this might surprise you, they can also be a creative one.
Let's start with the destruction, because it's staggering. Just think about the 2004 Indian Ocean earthquake and the tsunami that followed. An estimated 275,000 people lost their lives. It's just a heartbreaking reminder of the human cost.
And the danger isn't over when the ground stops shaking. It's like a horrible domino effect. You've got collapsing buildings, fires from broken gas lines, landslides, flash floods, and, of course, tsunamis, these giant waves that can literally cross oceans.
But, like I said, there's another side to the story. From the Earth's point of view, earthquakes are actually essential. They're part of how the planet stays healthy, how it releases all that pent-up energy. Believe it or not, they're actually a constructive force. For example, a quake in Japan back in 1923 literally lifted up parts of the seabed, creating new land. And when you zoom out, like way out, over millions of years, this is how mountain ranges are built. Earthquakes aren't just destructive. They're also part of the process that builds and shapes our world.
I mean, just look at this list of the biggest quakes ever recorded. A 9.5 in Chile? Can you even imagine that? These numbers are just off the charts. It really gives you a sense of the mind-boggling power we're talking about here.
So this brings us to the million-dollar question, doesn't it? We know why they happen, plate tectonics. We know where they happen, those hotspots. So, can we predict when?
The short answer? Not yet. As amazing as our science has become, being able to pinpoint the exact time and place of the next big one, well, it's still one of the toughest nuts for science to crack.
So maybe the biggest thing to take away from all this is a whole new way of looking at our planet. What if we stop thinking of the ground as this solid, stable thing? What if we see it as a living, breathing body that's constantly moving and changing? Because really, that's what's happening. These earthquakes, as scary as they are just a sign, a powerful, normal sign that our planet is very much alive.